Hello everyone, very good evening. I hope you all are doing well. Good evening, Lakshmi. Where were you? In yesterday's class, you were not there. Is everything okay? All fine, all good. So everyone doing questions? Okay, great, great. Everyone solving questions? Okay, there was network issue. Got it, got it. No issue. Just follow the previous class, okay? Either follow it from the YouTube channel or just take the help of some of your friends. Okay. How many of you did the homework? Not homework. I mean, are you people doing questions? I just wanted to know. Questions कर रहे हो तुम लोग? Okay, I hope you people are doing it. So कल के क्लास में हमने क्या पढ़ा था? Okay, Kiran, that's great. So it's, I mean, you are able to do questions, right? Some, yeah, that's great. That's great. Because this question solving thing will start with some only. I mean, you won't be able to solve all the questions initially. But if you are into practice, gradually things will become more easier. ठीक है चलो let's start with this. So कल के क्लास में हमने क्या पढ़ा था? We talked about dialectic. What is dialectic? So dialectic was basically insulator, है ना? And there were two types of dialectics. One was your polar, another was your non-polar. So no wonder, no matter what is the nature of dialectic, if we place dialectic in electric field, then inside electric field will get induced, and because of which net electric field inside the conductor, sorry, inside the dielectric will be less than the external electric field. जैसे केस कुछ ऐसा था, if this is dielectric and you are switching on electric field in this region, then this surface of insulator will have negative charge, this surface positive charge, such that electric field is getting induced. And value of induced electric field, I told you in the previous class, is less than value of external electric field. Done it? And net electric field inside the insulator or dielectric will be equal to E minus E induced. Okay? It was this. After that, we defined one thing, that was your, polarization. So polarization was what? Dipole moment generated per unit volume. और उसका वैल्यू कितना आया था? It was equal to sigma n. That is charge density induced on the surfaces. ठीक है? So we learned these things in the previous class. In today's class, we are going to see what is the effect of dielectric on capacitor. So let's check it. Okay? Let's start with it. Okay, so what we are going to do, first case one, we are going to study where we will be inserting dielectric in between the plates of capacitor. And here capacitor is isolated. What is the meaning of isolated capacitor? Isolated capacitor means capacitor which is not connected with any battery or voltage source or current source. ठीक है? जैसे यहाँ पे जो हमने capacitor लिया है, it has plus Q charge, it has minus Q charge, and it is now not connected to any battery. And what we are trying to do is we are trying to insert dielectric in this space. Done it? So if you see here, if on the plates of capacitor we have charge plus Q and minus Q, then there will be electric field in this region. Done it? Like this. So like this I have drawn. And if we are trying to drop dielectric in between the plates of capacitor having charge on it, actually we are dropping dielectric in a region which has electric field. You know? So if you will drop it here, it means you are dropping dielectric in a region having electric field. So what will happen? The same thing that happened yesterday. I mean, these dipoles will get aligned in the direction of electric field. Why? To become stable. ठीक है? So same thing will happen here. यहाँ पे dipole तुम्हारा क्या हो गया? ऐसे align हो जाएगा. And when this alignment thing is happening, what things will occur? This plus minus, this plus minus will get cancelled, and then there will be negative charge on one layer of the dielectric and positive charge on the other layer of the dielectric. So this was dielectric, and this dielectric we have inserted between the space of capacitor. So on the surface, on the left hand side surface, there will be negative charge, and on right hand side surface, there will be positive charge. Okay? And because of this induced charge on the dielectric, electric field is getting generated in this space, in this region. So initially, when there was no dielectric in the region of capacitor, when there was no dielectric in the space between capacitor, electric field value was what? It was equal to sigma by epsilon naught, where sigma is what? Sigma is charge density on the capacitor. Now there is one more electric field getting generated because of dielectric getting placed in between the plates, and that electric field direction is in this sense. So now what will be the net electric field inside the dielectric? So net electric field inside the dielectric will be E naught minus E induced. What is this E naught? E naught is basically this thing I'm calling as E naught. E naught means initial electric field that was there between the plates of capacitor when there was no dielectric. Then E naught. ठीक है? So इसको sigma naught मान सकते हो. This is surface charge density of the capacitor. ठीक है? सो नाउ ई नेट का वैल्यू आप क्या लिखने वाले हो? ई नॉट माइनस ई इंड्यूस्ड. एंड व्हाट इज द फॉर्मूला ऑफ ई नॉट? ई नॉट फॉर्मूला वी कैन राइट. ठीक है, क्या लिख सकते हैं हम? सिग्मा नॉट बाय एप्सिलॉन नॉट. एंड व्हाट विल बी द फॉर्मूला ऑफ ई इंड्यूस्ड? इफ यू रिमेंबर, दिस इज द डायलेक्ट्रिक, राइट? इस स्पेस में डायलेक्ट्रिक ऐसा था, दिस वाज नेगेटिव प्लेट, दिस वाज पॉजिटिव प्लेट, positive side of the capacitor, and electric field induces like this. So if you see here carefully, this dielectric also seems like there is one surface on the left hand side, another surface on the right hand side. On this surface, there is negative charge. On this surface, there is positive charge. So to calculate the value of electric field because of induced charges, what formula we can use? We can simply use the same formula, sigma by epsilon naught, where sigma will be the charge density of the induced charge, right? So E naught को आप क्या लिखने वाले हो? Sigma naught by epsilon naught. What will be E induced? What will be induced electric field? So that is your sigma induced by epsilon naught. ठीक है, समझ रहे हो ये दोनों चीजें? So sigma naught is what? It is your Q by epsilon naught. What is this? This is your sigma naught. What is this sigma induced? So this is charge induced on the surface of dielectric. So it is this charge induced on the surface of dielectric divided by area लिखना है ना मुझे, epsilon naught नहीं, sigma naught क्या है? Charge density है ना, so area लिखोगे यहाँ. Same area here A we will be writing. Why same area we are taking? Because dielectric is covering or is occupying the whole region in between the plates of capacitor. So if this plate has area A, then this region of dielectric also has what? Area A. So sigma induced is this. Now we can put in values. I mean, we can calculate it like this: sigma naught minus sigma epsilon naught. And how this sigma naught and sigma induced are related. This is the thing here. So sigma induced को हम क्या लिखते हैं? This is sigma naught by K. This is by experimental thing. This we can derive, but that's not in our thing. I mean, this we don't need to cover. So we just need to remember sigma induced will be equal to how much? Sigma naught by K. Where sigma naught is what? Charge density on the capacity. K is what? Dielectric constant of the dielectric. Okay? So this is this. If this is the case, then this, okay, this can be, I did one mistake here. एक काम करो, I mean, एक second, sigma induced is not this. Sorry. So sigma induced nahi, this overall can be written as sigma naught minus sigma induced. I mean total surface charge density now. This can be written as sigma naught by K. This whole is equal to sigma naught by K. I'm really sorry. So sigma induced को accordingly we can calculate from here. Sigma induced को आप क्या लिख सकते हो यहाँ से? Sigma naught minus sigma naught by K. So this is equal to sigma naught 1 minus 1 by K. This is sigma induced. ठीक है, but sigma naught minus sigma induced is sigma naught by k. So this whole is equal to sigma naught by k, and if we write it here, sigma naught by k epsilon naught will become the net electric field, and hence net electric field is equal to what? Sigma naught by epsilon naught is the original electric field, that is E naught. So net electric field is now external electric field present already divided by k, that is dielectric constant of the uh, dielectric. ठीक है, so what happened to the electric field in between the plates of capacitor when we are dropping dielectric in its space? क्या हुआ? Electric field simply got decreased by k times, so it became E naught by k, where k is the dielectric constant. What are the things we need to remember? Only this thing: sigma naught minus sigma induced is sigma naught by k. This thing we need to remember. And from here, you can calculate sigma induced. That also you should keep in your mind. Done it? So यहाँ से ये चीजें हम निकाल सकते हैं. Now, if we talk about E net is how much? This is your E naught by K. Now we can talk about what will be the effect on potential difference. So potential difference को हमने क्या लिखा था? V equal to हमने क्या लिखा था? ED. V equal to क्या था? ED. So when you are inserting dielectric in between the space of capacitor, D is not changing, right? Separation between plates still same. So D is constant. Electric field is getting decreased by K times. So new potential will also get decreased by what? K times. So effect on potential will be how much? Effect on potential will be that if initial potential is V naught, which is equal to sigma naught by epsilon naught into D. So what will be the new potential? That will be net electric field. Okay, so this is your net electric field into D. ठीक है, so net electric field is your what? This is your sigma naught by epsilon naught into K times into D. So sigma naught by epsilon naught into D is equal to how much? V naught. So this is looking like 1 by K into sigma naught D by epsilon naught. So this is equal to 1 by K into potential difference. That is, I mean 1 by K times initial potential difference. So what is the effect on potential here? Potential is getting decreased by K times. Okay. So effect on potential, you can note here V naught, initial potential, if it is V naught, then it will become V naught by K. So it is getting decreased by K times. Now what will be the effect on charge? Many of you will just rush towards thinking that charge on capacitor will decrease, but it is not going to happen. Just see here, this is the capacitor plate. Okay, this is your plus Q, this is your minus Q, and then there is this dielectric जो कि just इस space को fill कर रहा है, ऐसे touch करता हो almost ऐसा. And what is happening in this dielectric? In this dielectric, charge is getting accumulated. This side negative charge, this side positive charge. You may think like charge on this plate of capacitor. Let's say this negative induced charge is equal to Q induced minus Q induced, and this is equal to how much? Plus Q induced. So you may think like charge on the plate, on this plate containing plus Q amount of charge on it will finally become Q minus Q induced. है ना, सोच सकते हैं हम, क्योंकि इस प्लेट पे पॉजिटिव चार्ज था and because of dielectric here charge coming is negative. So you can think like charge on the first plate of capacitor will become how much? Q minus Q induced. But this thing will only happen if this negative charge getting induced because of dielectric will be able to travel to the plate. ठीक है, तभी चार्ज घटेगा, है ना. If this negative charge is not able to travel to the plate, then this charge will remain unaffected, right? So will it be able to travel? Dielectric is what? Dielectric का मतलब आप क्या समझते हो? Dielectric means insulator. So this plate is a conductor, and here there is a insulating layer. This is insulating layer, and on this insulator there is negative charge induced. So between this negative charge induced, there is an insulator layer, and this charge won't be able to travel to the conducting plate. Okay, so there won't be any transfer of charge. Okay, so charge on capacitor, if initially was plus q naught and minus q naught, finally it will also remain plus q naught and minus q naught. Okay, charge is not going to change, so no change on the charge on capacitor, no change. ठीक है, एंड ऑल्सो दैट इज व्हाई वी कॉल इट आइसोलेटेड कैपेसिटर. मैंने बोला आइसोलेटेड कैपेसिटर पे आप क्या डाल रहे हो, डाइलेक्ट्रिक डाल रहे हो. So this is isolated capacitor. Wherever you encounter isolated capacitor, charge will remain constant. Charge constant always. Because dielectric के डालने से whatever charge is getting induced won't be able to travel to the plate, because dielectric is an insulator. From insulator you cannot transfer charge to conductor. There is that insulating gap between these two, so it won't be able to travel to there. Okay, so charge will remain constant. Now what is the effect on capacitance? Capacitance कल भी मैंने बताया था effect क्या होगा. So what will be the effect? C को क्या लिखते हैं हम, C नॉट क्या लिखेंगे, without dielectric epsilon नॉट A by D. This is your what? Without dielectric, है ना, this is without dielectric. Now, what will happen if we are inserting dielectric? Let's say capacitance is C. So epsilon naught is permittivity in vacuum. In any other media, any other dielectric, it will become epsilon A by D. And you already know epsilon is equal to epsilon naught epsilon R. ठीक है, so epsilon की जगह आप क्या लिखने वाले हो, epsilon naught epsilon R A by D. This can be written as what? Epsilon R, epsilon naught A by D. And this is equal to initial capacitance. So this is C, and epsilon R is relative permittivity, which is also called dielectric constant. So epsilon R or K तुम्हारा क्या है? These are same things. So here I will be writing Kc naught. ठीक है? Mahesh, is it fine?
Yes, ma'am.
Okay. Okay, so capacity is getting increased, and if just now you saw capacity has increased, and let's say your capacitor was charged to its maximum capacity, and now after insertion of dielectric, capacity has increased. It means if you connect it with battery, then it will draw some more charge from the battery. Why? Because it has got charge. Its capacity has increased. That is why. Okay. So if you are inserting dielectric in between the space of capacitor, its capacity will go what? Its capacity will increase by k times. Okay. What will be the effect on energy? Energy को आप कैसे लिखते हो? Initial energy क्या लिखोगे? Half C naught V naught का square, या फिर क्या लिखोगे? Q naught square by 2C. ठीक है, let's traverse with the help of this equation. You can also use this equation to see the change in energy. So Q naught square by 2C is what? E naught. ठीक है, and if you calculate what final energy after the insertion of dielectric, so let's indicate it by letter E. E will be equal to how much? Q is not going to change, right? So Q to Q naught ही रहेगा, because just now we have seen even after inserting dielectric, charge is not going to change. So Q naught square 2. C का क्या होगा? Initially it was C naught. C का क्या status होगा? Yes, Kiran. Yeah, correct. So C क्या हो जाएगा तुम्हारा? Here it will become KC naught. So if you see here carefully, it is becoming 1 by K Q naught square by 2C. 2C naught. So Q naught square by 2C naught was the initial energy, and now energy is what? E naught by K. So energy will get decreased by K times. You can also use the another formula to check this one. इसको भी use कर सकते हो. Finally energy को क्या लिखोगे? Half C. C क्या हो जाएगा? K C naught times. What will happen to the potential difference? We have already seen it will get decreased by K times. So you will write V naught by K ka square. So if you check it, it will become how much? Half C naught V naught ka square into 1 by K. So again, initial energy by K. So energy will get decreased by K times. Done it? I will summarize everything here. Let me do this. Electric field का change हमने पढ़ा. We saw what will be change on the potential difference. We saw what will be change on the charge. We saw what will be the change on energy. And what else is left? Yes, what is the effect on capacitance? Okay, so energy became what? K naught times it got decreased. Potential, it also got decreased by K times. Charge, it remained constant. Same. In this is energy मैंने यहाँ लिख दिया. Electric field भी तुम्हारा K naught times घटा था. So you can write it like this. Okay. Let's say we talked about energy already. Let's call it electric field. Then electric field also got decreased by K naught times. Capacitance got increased by K times. So this is whole the summary. And when this happened, when we are inserting dielectric in plate in between the space of capacitor, when capacitor is not connected to the battery, that is we are inserting dielectric in an isolated capacitor. Okay? So these were the things we got. Now, let's do one question. After that, we will move ahead. Question अगर दिखने में छोटा लग रहा है, I couldn't extend it actually. So I will read to you. Diagram देखो कुछ ऐसा है. This plate is having charge plus Q, and this is having charge minus Q. There are two dielectrics added there. One is K1, another is K2. ठीक है? The variation of electric field E between plates with distance D as measured from P is correctly shown by which diagram? So there are two dielectrics here. In this region, this one. In this region, this one. So this is your K1 and this is your K2. K1 is less than what? K1 is less than K2. You have to talk about how the electric field in this region will change. Okay? So check it, how it will change. Check with the graph. Try to see which one will be correct. Okay? Okay, I got one answer, two answers, and it seems incorrect. Okay, one more answer. Chalo, ठीक है. I will be ending the poll now. But you people tried it. That's very good. Maybe some of you have got it correct. Let's see here. What will happen? I mean, this is the plate, right? This is the plate. Up to certain region, there is no dielectric. है ना? In this space, there is no dielectric. So in this region, electric field will be E naught. Done it? So in this region, electric field is what? E naught. Done it? And Dhruv, yeah, it feels correct. Let's see. Okay. So in this region, electric field is what? E naught. Now let's check with the region of dielectric, because just after this region, there is one dielectric. And in this region, dielectric constant is what? K1. And in this region, electric field will be how much? E naught by K1. So certainly less than E1, because K1 will be always greater than 1. Dielectric constant is greater than 1. So here E naught by K1, it will be great. I mean, I always use the term electric field is decreasing. That means K1 or dielectric constant is going to be greater than 1. Okay. So this is this. Again, there is some empty space, no dielectric in this region. Vacuum is there, let's say. So again, in this region, electric field will be how much? E naught. Again, there is dielectric here. So in this region, electric field will be how much? E naught by K2. And remember, K1 is less than K2. So, E naught by K1 और E naught by K2 में कौन बड़ा होगा बताओ? K1 is less than K2. K1 is less than K2. So, E naught by K1 will be greater than E naught by K2. ठीक है? And again in this space, electric field will be E naught. Now you can check with the equation what you are getting. Okay, Kiran? It feels correct. Let's check now. So electric field initially, अगर मैं कुछ distance तक की बात करूँ, तो let's say this is x1 distance. So up to x1 distance, electric field is E naught. Let's say this is E naught. ठीक है? Now from x1 to x2 distance, from here to here, electric field is how much? E naught by k1, which is less than E naught. So less than E naught, तो नीचे जाओ थोड़ा और यहाँ पे line बनाओ. And this electric field value is from x1 to x2. Sorted. Now from x2 to x3, let's say this is x3 point. So from x2 to x3, electric field is again E naught. So it will again jump to this situation, and here electric field is how much? E naught up to x3. And now what will happen from x3 to x4? Again electric field is how much? Sorry, मैंने गलत तो नहीं बनाया. x2 x3 बनाया, x3 और ये रीजन मैं छोड़ रही हूँ, x4 इसको बुलाओ, इसको x5 बुलाओ. ठीक है? x3 x4 के बीच में क्या होगा? इलेक्ट्रिक फील्ड E naught by K2, which is even more smaller than this. So here you will be writing what? You will be going more down. So let's say it is here. I mean below this you have to draw. ठीक है? So up to x4 it is this. Now x4 to x5, again electric field is how much? It is E naught. So from here to here. Then which is going to be the correct answer?
C.
It is C. Huh. So C will be your correct answer. Then, so these are the sort of question we may be asked. चलो हमने इलेक्ट्रिक फील्ड समझा. Now let's discuss another case, case 2, where we are inserting dielectric when capacitor is connected with the battery. So battery is there. अब देखो इसको explain करना is more easier because we have already understood the first case. So let's talk about this first. अगर आप okay, you can unmute yourself. I mean, sorry, mute yourself. I'm not unmuting everybody so that you can answer in between or you can ask your doubts. Okay? So please take care of that. Now what will happen here? Let's check with it. Okay, Lakshmi. I will show the previous slide. Do it. Okay. Okay, thank you. So let's talk about this case. Now this plates are connected with the battery and then we are bringing dielectric in between the plates. Then what are the things going to happen? तो सबसे पहले मैं ये बता दूं, यहाँ पे देखो, this point will have a potential of let's say V plus and this has a potential of V minus such that V plus minus V minus is equal to V. This thing we have already done so much. This is a positive terminal and that is why I've given it positive potential. This was a negative terminal and that is why I've given it negative potential. If you talk about this potential thing, then this point will have potential of V plus and this point will have potential of V minus. What is its meaning? Its meaning is simple. On this, the potential of left plate is V plus, potential of right plate is V minus. What is the potential difference of plate at all time? I mean at any instant, if you say, what is the potential difference? V plus minus V minus. That is V. Let's call it V naught. Okay? Now you're bringing the dielectric in between the space. Even if you are bringing dielectric in between space, I mean, what will happen then? You know, because of battery, plates के बीच का potential is V naught. You are bringing the dielectric, there will be this thing happening, same as before we did. ठीक है? This side negative charge will accumulate, this side positive charge will accumulate, such that electric field will get induced. ठीक है? So let's say electric field got induced. Yes, it will get induced because dielectric is kept in external electric field, and net electric field, you will feel like, let's write it E naught minus A induced, the thing we did before. And if you see here, then you will say that कि चलो calculation के बाद E net will be E naught by K, and then you will try to reach to the conclusion that potential finally will be V naught by K. But this is not going to be the case. क्यों? क्योंकि this battery will make sure that this plate is always at V plus and this plate is always at V minus. So potential difference between the plates will always remain V naught. It is not going to change from V naught. And hence electric field, which is equal to Vd, if V is not changing, D is not changing because we are not changing distance between plates, electric field will also not change. So you may be getting confused कि कैसे change नहीं करेगा. It was initially E naught, now E induced is coming. This subtraction thing will happen. So electric field should change, but according to battery, you can see potential difference will be V naught always. So हमने अभी तक जो concept पढ़ा, and by looking at the battery, two things are contradicting each other. Let's understand this contradiction. Just now I told you, when you insert dielectric in between the space of capacitor, its capacity increases by K times. So its capacity is going to increase. Now, if capacity has increased, what does it mean? इसका सिंपल मतलब ये है कि now this plate will draw more charge from the battery. So some extra additional charge will flow like this. ठीक है? Yes, potential is not changing क्योंकि मैंने तुम लोगों को बताया ना, जैसे बैटरी से अगर तुमने किसी चीज को जोड़ दिया, लेट्स से ओके, सब किसी का डाउट है कि मैं सेम क्यों कह रही हूँ, बिकॉज इट इज कनेक्टेड विद अ बैटरी ऑफ पोटेंशियल V, राइट? V नॉट, लेट्स से दिस इज V नॉट. सो अगर तुम्हारे पास सपोज कर लो यहाँ पे ऐसा है, बैटरी है, इसका पोटेंशियल डिफरेंस V नॉट है, एंड इफ टू एंड्स ऑफ रजिस्टर इज कनेक्टेड विद दिस बैटरी A and B, then always you can say potential difference across A and B is V naught, because this whole V naught will drop across the resistor. There is only one electrical device. Similarly, if you are having capacitor and you are connecting it with a battery like this, its potential is V naught. So its potential will drop where? There is only one device in the circuit, that is this capacitor. So on this capacitor, potential will drop, that will be equal to V naught. So to the long this capacitor is connected to the battery, potential difference across it will be same, that is V naught. Done it? That is why I'm trying to say you is, even if you are inserting dielectric in between the space of capacitor, this potential difference is not going to change because two plates of capacitor are connected to the terminals of a battery. So that will make sure always potential difference across capacitor is equal to certain value, and that certain value is equal to the EMF of the battery in this case. ठीक है? तो इसलिए मैंने बोला ये V नॉट होगा, लेकिन जो हमने कॉन्सेप्ट पढ़ा उसके अकॉर्डिंग वी नो दैट इंड्यूस इलेक्ट्रिक फील्ड विल कम because of this insertion of dielectric, and if induced electric field will come, then net electric field should decrease and hence net potential should decrease. But it is not happening. Why? This why I wanted to answer. So what I'm saying is, since you have inserted dielectric in between the space of capacitor, its capacity has increased, and let's say in the case where capacity has increased, it will draw more current from the from the battery. So let's say it has drawn plus Q induced value of charge, and from here minus Q induced value of charge, it has drawn from the battery. तो मैंने ये क्यों लिखा है? क्योंकि देखो, इलेक्ट्रिक फील्ड चेंज क्यों हो रहा था? बिकॉज नेगेटिव चार्ज वाज गेटिंग इंड्यूस्ड ऑन द वन surface of dialectic, positive on the another surface of dialectic. This was your minus q induced and this was your plus q induced. ठीक है? An electric field was getting generated in this case. Now if on this side where plus q induced was coming, what if we supplied more minus q induced charge? Overall thing will remain same, right? I mean, if minus q induced it is gaining extra, and if it is gaining plus q induced extra from the battery, then whatever electric field is trying to change because of induced charge on the dielectric, that electric field change will get compensated by extra charge that this capacitor is drawing from the battery. ठीक है? So समझ रहे हो ना? इंड्यूस्ड इलेक्ट्रिक फील्ड की वजह से इलेक्ट्रिक फील्ड किधर हुआ? इधर हुआ. एंड सेम अमाउंट ऑफ इलेक्ट्रिक फील्ड इज गेटिंग जनरेटेड बाय extra charge traveling to the capacitor from the battery, but in opposite direction, in this direction. So overall it will get nullified. This will get nullified, and you will, and it will feel like potential across the capacitor is always V naught. So basically, when capacitor is connected to the battery, potential or electric field will not change because its capacity will increase because of insertion of dielectric. Because of increased capacity, it can draw charge from the battery. Here there is a battery, so it will draw those additional charges. And that value of additional charge I'm saying here, it will be equal to this, such that net electric field will not change. So effect on potential what? V naught will be constant because it is connected with the battery. And what will happen to the effect on electric field? Electric field will also remain constant because potential difference is not changing. Capacitance, as usual, it will get increased by k times. क्योंकि मैंने explain करने के लिए भी बताया, capacity is increasing, that is why it is drawing more charges. It is drawing as much charge that can cancel out the effect of A induced, right? So capacity is increasing. What is effect on the charge? Yes, charge is getting increased by k times. ठीक है? So you already know this formula, Q equal to CV. ठीक है? So if V is not changing, V is remaining same, C is getting increased by k times, Q will get increased by k times. So K Q naught. ठीक है? This is this effect of energy. What will be the effect on energy? Just write the formula, half CV square. V is not changing, right? V is remaining what? Constant. C is increasing by k times. So if you write initial energy as half C naught V naught square, what will be final energy after inserting dielectric? Half C will become K C naught, V naught will remain same. So this energy here is becoming K times. It is getting increased by k times. In the previous case, that was getting decreased by k times. So this is happening. ठीक है? Done है? किसी को डाउट है तो बताओ मुझे. Any doubt is appreciated. Anybody can ask. Yes, you can unmute yourself and ask. ओके, पोटेंशियल को फिर से एक्सप्लेन करो. चलो ठीक है, कोई नहीं, आई विल डू इट. सो लेट्स टॉक अबाउट दिस थिंग. ये तुम लोगों को कंफ्यूज कर रहा है ना? सो लेट्स टॉक अबाउट दिस. देखो, इलेक्ट्रिक फील्ड की बात करते हैं. ठीक है? सो कैपेसिटर ऐसा था. ठीक है? व्हाट इज द इलेक्ट्रिक फील्ड इन दिस स्पेस? Let's say this plate has a charge of q naught plus q naught and this plate has a charge of minus q naught. So let's write the E naught ka value. E naught value is how much? Q naught by A epsilon naught, that is sigma naught by epsilon naught. This is the electric field. Everyone agree, right? Now what we are doing, we are inserting dielectric. तो चलो हमने डाल दिया dielectric. और तुम्हें एक चीज तो पता है कि because of dielectric what happens? और डायलेक्ट्रिक को जब हम इलेक्ट्रिक फील्ड में डालते हैं, देन व्हाट हैपेंस व्हेन वी ड्रॉप डायलेक्ट्रिक इन इलेक्ट्रिक फील्ड? then in electric field gets induced inside the dielectric such that negative charge will be here. Agar electric field इस direction में है, then positive charge on the dielectric will accumulate in the direction of electric field. Negative charge opposite to it. This was the direction of E naught, such that electric field is getting induced. E induced. And you will write here what? E induced को आप क्या लिखोगे? You will simply write here E induced is equal to Q induced by A epsilon naught. ठीक है? What is the net value of electric field? You write it like this. Q naught, दोनों को minus करोगे, Q naught minus Q induced by A epsilon naught. So electric field is getting decreased overall. We have learned. क्योंकि Q naught minus Q induced by A को हमने sigma naught by K बोला था. ठीक है? So this is getting decreased. We can see like this. लेकिन suppose कर लो, अब मैंने क्या किया? Suppose कर लो मेरे पास एक डिवाइस है जिसके हेल्प से पहले इसके पास कितना चार्ज था? प्लस क्यू नॉट चार्ज था. सो दिस इज द इनिशियल केस. ठीक है, ऐसे मैंने एक्सप्लेन किया. नाउ व्हाट वी आर डूइंग इज वी आर गिविंग इट सम एक्स्ट्रा चार्ज. हाउ मच एक्स्ट्रा चार्ज? प्लस क्यू इंड्यूस्ड आई एम गिविंग इट. ठीक है, एंड आई एम गिविंग इट एक्स्ट्रा चार्ज माइनस क्यू इंड्यूस्ड टू दिस प्लेट. ठीक है, सो नाउ इफ यू गो ऑन टू राइट ई इन, आई मीन now let's talk about writing this E naught and this E induced again. So E naught now आप कैसे लिखोगे बताओ? अब इलेक्ट्रिक फील्ड को आप कैसे लिखोगे? It has got some additional charge plus Q induced. So this will become Q naught plus Q induced by A epsilon naught. ऐसे लिखोगे क्यों? Because this is connected with a battery and that battery is supplying it with additional charge. I have taken that additional charge to be equal to plus Q induced to the positive plate minus Q induced to the negative plate. So now this capacitor is looking like it has a charge of Q plus Q induced and it has a charge of minus of Q plus Q induced. It's like this. So I've written E naught like this. What will be the value of E induced? That is same Q induced by A epsilon naught. Now if you subtract these two, E net निकालने के लिए अब आप इन दोनों को subtract करो. If you will subtract it, you will get like Q naught by A epsilon naught. Same. You're getting the same, right? So why this same thing we are getting? Because there was a battery which supplied this capacitor with charge. How much charge? As much charge that can make sure potential difference or electric field across the plates of capacitor remain same. Why same? Because जब भी तुमने इसके आई मीन यू आर कनेक्टिंग प्लेट्स विद द बैटरी, सो बैटरी को देखने से ऐसा लग रहा है दिस प्लेट विल बी ऑलवेज एट V प्लस, दिस प्लेट विल बी ऑलवेज एट V माइनस. सो इफ समथिंग इज ट्राइंग टू चेंज दिस इक्वेशन, दिस बैटरी विल डू समथिंग. ठीक है, it will do something that will make sure potential difference stays same. And what is that something getting done here by the battery? That something is additional charge getting supplied to the positive and negative plate such that electric field or potential difference across the plate remain same. ठीक है, so everyone agree? This thing I wrote without the battery and this thing I wrote with battery. ठीक है, थैंक यू किरण, थैंक यू सो मच. किसी और को कोई डाउट है तो लेट मी नो. यस, एनीबडी? नो वन? So let's do some question because we have finished this capacitor thing. We will do questions. Okay, so let's do it and read the question carefully. Take your time. Try solving it. अच्छा तुम लोग एक काम करो, मुझे ना अभी क्वेश्चन को भूल जाओ, मुझे एक चीज बताओ। वी आर एडिंग हियर थ्री डायलेक्टिक्स, राइट? सो फर्स्ट क्वेश्चन मेरा ये है, हाउ मेनी कैपेसिटर्स यू कैन सी हियर? हाउ मेनी कैपेसिटर? फर्स्ट क्वेश्चन. Second question, if you I mean, if you have already thought of how many capacitors are there, then tell me, are they in series or parallel? ठीक है, ये दो चीजें पहले मुझे बताओ। वेनु, दो दिख रहा है तुम्हें? दो प्लेट्स दिख रहे हैं ना, मेकिंग वन कैपेसिटर। लेकिन कैपेसिटर्स कितने हैं? ओके, यू जस्ट डू वन थिंग, गिव मी 1 minute ऑफ टाइम। आई विल रीशेयर द स्लाइड, ठीक है? क्योंकि you won't be able to do this question instantly. I need to do something different. So just give me 1 minute. I hope you will wait patiently. Just give me some time, ठीक है? ठीक है, we will revise it, ठीक है? हम लोग ऐसे करेंगे so that we can understand more things, so that we can do all sort of questions. So give me some time for that. चलो ठीक है, I will resave. So let's start with a basic thing. Okay, one capacitor parallel दिख रहा है? नहीं, तुम लोग समझ नहीं पा रहे हो मैं जो पूछ रही हूँ। सो दैट इज वाई लेट्स डू सम एक्सरसाइज। ठीक है, सो सपोज कर लो यहाँ पे सिंगल, ये कितने कैपेसिटर है? एक कैपेसिटर है। एक कैपेसिटर का मतलब टू पैरेलल प्लेट्स, सो दिस इज वन कैपेसिटर। एंड इफ डायलेक्ट्रिक वी आर एडिंग ओवर हियर, initially if capacitance was C naught, finally it is K C naught. If its dielectric constant is K. Now let's say we are drawing different things like this. Suppose we have a capacitor, parallel plate capacitor, and we are inserting two dielectrics such that in half of the space, in this space, I have added K1 dielectric, and in another space, I have added K2 dielectrics. अब बताओ, what can I tell about the final capacity of this capacitor in the second diagram? In the first diagram, we can clearly say this is Kc naught because in the whole space, K dielectric is there, right? In second diagram, in half of the space, there is K1 dielectric. In another half, there is K2 dielectric. What will be C final? What will be C final? अगर initially value C naught है तो this is C initial. How you will go around it? So you just think like, I mean, this space between capacitor is getting divided into two regions because of the dialectic. This is reason one, this is reason two. Okay? So let's imagine an imaginary plate here. Let's imagine one imaginary plate here. Okay? And if we imagine imaginary plate here, then we can feel like this capacitor can be drawn like this. This is one capacitor having dielectric constant K1, and then this is another capacitor having dielectric K2. So two capacitors we can see. Then one having dielectric K1 and another having dielectric K2. किरण, नहीं ऐसे भी नहीं बोल सकते, पहले हमें सीरीज पैरेलल देखना पड़ेगा। सो अब आप ध्यान से सोचो कि ये दोनों कैपेसिटर सीरीज में है या पैरेलल में है। सो थिंक अबाउट दिस नाउ। So let's say this plate has a potential of V1. This plate has a potential of V2. Imaginary plate को आप कुछ भी potential दो because this imaginary plate will not have potential V1 because it's not connected with plate 1. Similarly, this imaginary plate won't carry the potential of second plate because it is not connected to second plate. Let's say its potential is V3. So you can clearly see here one thing. Potential difference between this plate is V1 minus V3. Between these two plate is V3 minus V2. Potential difference is different, so they are in series or parallel. Not Kanus, it won't look like this. It is they're in series, right? So this diagram now can be drawn as this. There are two capacitors, one having capacitance, one having dielectric K1, another having dielectric K2. Here the distance between plate is d by 2. Here the distance between plate is also d by 2. Area of plate is remaining same as the original one, that is A. So what is the capacitance of this first capacitor? Let's say this is C1. Let's say for this is C2. So C1 और C2 का value आप क्या बोलोगे बताओ? Yes, Lakshmi. They're in series. So in series, पहले तो C1 का value लिख डालो. So that will become K1 into epsilon naught A by D by 2. Will it be true? Because if this region has no dielectric, if C1 has no dielectric, then its capacitance will be epsilon naught A by D by 2. So this, it has dielectric. So K1 into this. Epsilon naught A by D किसके बराबर है? C naught. क्योंकि initial capacity of this capacitance without dielectric was given as C naught. So C naught was equal to epsilon naught A by D. ठीक है? So here you can write it like 2K1 C naught and C2 will become equal to how much? 2K2 C naught. They are in series. Add them like in parallel because that is how we add capacitors in series. So 1 by C equivalent is 1 by 2K1 C naught plus 1 by 2K2 C naught. If you go on to solve it, this will become how much? 1 by 2 C naught को आप common ले लो. So this is K1 plus K2 by K1, K2. So what is going to be the C equivalent? This is equal to how much? 2 C naught K1, K2 divided by K1 plus K2. So there was this capacitor initially. This distance between was D, area was A. So initial capacitance was epsilon naught A by D. We added dielectric in the two regions. Here K1, here K2. Then dielectric became how much? 2 C naught K1, K2 by K1 plus K2. So you may be asked question like, what can we, we have added two dielectric here. Can we replace this two dielectric with a single dielectric such that C equivalent will remain same? So let's say we are adding single dielectric K dash such that C equivalent is remaining same. So new capacitance will be K dash C naught and C equivalent has to remain same. So that will be equal to this. So if you equate it, you will get 2 C naught K1, K2 divided by K1 plus K2. So what can be the single dielectric in place of 2? That can be equal to K dash equal to 2 K1, K2 by K1 plus K2. ठीक है? So first हमने क्या किया? First हमने ये सीखा कि how capacitors get divided when we are adding different dielectrics. Not single dielectric, two dielectrics, three dielectrics. So हमने यहाँ पे two dielectric use किया था. It divided capacitor into two regions and we got two capacitor. Both were in series, right? चलो अभी कुछ और identify करते हैं. Let's do it. So let's say in the first case itself, we are now also adding dielectric, but in a different way. Its initial, this area is A, this separation is D. So C naught is equal to epsilon naught A by D. Now what we are doing, we are adding dielectric in two regions. Now we are adding dielectric like this. In this space K1, in this space K2. Now tell me how many capacitors we are getting because of addition of dielectric. Will they be in series or parallel? Try checking. Think around it. Yes. One capacitor parallel. कैसे दिख रहा है बताओ? तुम लोग अभी समझ नहीं पा रहे. यू नीड टू डू लॉट्स ऑफ प्रैक्टिस. प्लीज तुम लोग क्लास के बाद बहुत सारे कैपेसिटर को लेकर बैठना और सोचना. जब तक सोचोगे नहीं समझोगे नहीं. ठीक है? सो तुम लोग प्लीज करना. यस किरण, मैं देखो फिर से डिस्कस करती हूँ। जैसे देखो, वी आर गेटिंग टू रीजन्स, राइट? दिस इज वन रीजन having dialectic K1, this is another region having dialectic K2. तो सबसे पहले ये सोचना कि in how many regions dialectic is dividing the capacitor. So in this case, you can clearly see dielectric is dividing capacitor into two regions, and hence there will be two capacitor getting generated. ठीक है? So दो कैपेसिटर जनरेट हुआ, और ये दो कैपेसिटर कैसे दिखेंगे इसको मैं बनाती हूँ। एक है ऐसा जिसके बीच में K1 डायलेक्ट्रिक है, और दूसरा है ऐसा जिसके बीच में K2 डायलेक्ट्रिक। Now, this half region will make one capacitor, this another region will make another capacitor. देखो जैसे मैंने यहाँ पे बनाया। अब देखो, if I talk about this plate 1, then this is also plate 1, है ना? This is plate 1, let's say, this is also plate 1, plate 2. This is plate 2, this is plate 1. So this plate of first capacitor is the part of first plate. This plate of second capacitor is the part of first plate. So this is also first plate. And this is 1, and this is, sorry, this is 2, and this is part of second plate. Now we are getting two capacitors, right? इन दोनों capacitors को अब आप और ध्यान से देखो। ये दोनों capacitors का एक चीज clear है, distance between them is still same, that is d, but area has decreased a by 2, because in half there is K1 dielectric, in another half there is K2 dielectric. So in this space there is what? This is also a by 2, and this is d. Dielectric is K2. Now the question is, will they be in series or parallel? So let's say this one plate is at a potential V1, this second plate is at a potential V2. So this plate will have potential V1, this plate V2. Similarly, this will have potential V1 because it is the part of first plate itself, and this will have a potential V2. So potential difference between these two is same, they will be in parallel. So in this case, we are getting two capacitors like this. They are in parallel. It has a dielectric of K1, it has a dielectric of K2. So let's say this is C1, this is C2. C1 को आप क्या लिखोगे? You will write it K1 epsilon naught, इसका area कितना area है? A by 2 divided by D. What is C2? That is your K2 epsilon naught, its area. So that is A by 2 by D. Why I am writing K1 before? क्योंकि तुम्हें पता है, if you have a dielectric of area A by 2, distance separation D, then its capacity without dielectric will be equal to how much? Epsilon naught A by 2 here into D. So this is, and since there is K1 dielectric, you will write here K1 into this, because dielectric will get increased by K times. So that is why I've written here like this. Now you can add them in series or parallel, and that way you will be able to move ahead. So in the tomorrow's class, what we will do is we will do some more questions. Done it? We will, I will pick some more questions so that we can practice this series parallel thing with dialectic more. Done it? लेकिन पहले से भी तुम लोग भी करके आना. You will do it, right? So you just pick 3 or 4 questions and try doing it. Just pick the NCERT book. There also you will get some diagram of capacitor with inductor. Try solving at least those questions. That will help you a lot in understanding whatever I have tried to teach you. ठीक है? चलो. Any doubt, anybody? Anyone having any doubt? No? Yes, Lakshmi, you can find these recorded sessions on Avanti Live One channel. There is one YouTube channel that is your uh, Avanti Live One, and there you will get on. I mean, there will be playlist named 2025 Station Class 12 something. Okay, so there you can get. Or if you're not able to get it right now, I can say just wait for some minute. Okay, just give me some time. I will be sending in the. Okay, it is live too. That is why I said let me check. Okay, it's live too. Thank you, Kiran. I can share it now. Just give me some minute.